The most common belief in the test automation world is that record and playback is highly unreliable. For some tools, it is indeed true. For tools where the generated test files are not humanly readable, for tools where you do not have enough control over the underlying code base, and for tools where you're not sure how the actions are, how the actions are performing, in those cases, this kind of a negative opinion is indeed true. But with kids, we are going to see how the situation is drastically different. With kids, we have complete control over the object properties identified during recording and spying. We can change the priority of these attributes during execution. We can completely delete them, create our own, so much so that we can even make it completely data driven by dynamically changing these attributes at runtime. Let's see how. So in this video, we are going to see how we can change the object properties as we just discussed, and how we can even change the priority of the attributes using which the objects would be identified on the screen. But before we change anything, let's look at this test case, which was created during the recording, and the last step was added by spying. So before we make any change to the script, let's quickly run this one and see how stable it is. In order to run this, we have to click on this run button. But before that, we right click and we select which browser we want. So I'm going to select the Chrome browser. I will create a separate video on test execution in details, where we're going to run single test cases, multiple test cases in a test set, but that's for a later period of time. Now I'm just going to run this to see whether this script which was recorded is going to run at all, or it's going to fail at multiple points. So I've selected the browser as Chrome, and I'm just going to click on run, and I see the browser coming up, and it's waiting on this page, probably because there are some assertions. It's scrolling up and down because it's capturing screenshots if there are passes or failures, and then it closes. So we see in 23 seconds the entire test case was completed, and we see a detailed report. I'm also going to cover how to read the report later on, but as of now, if we click on the name of the test case, TC1 here, it opens up um, every step that the tool performed while creating this flow. And yeah, as we had predicted right at the very end, it was taking some screenshots. So if I click on this pass, you will see a full page screenshot. That is why we could see the screen going up and down. Um, so the basic conclusion is the script which was recorded is running properly. Okay, but I want to make it data driven. I want to make it in a way that I'm not dependent on the properties that the tool captured for me, but I want to define the properties myself. So in order to do that, uh, let's look at any object, for example, username, and I see that the name, the ID, relative XPath class, CSS text were captured. Now, it is interesting to see that this application has pretty well defined attributes. I'm going to the application. If I go to all items, let me just log into this application. Okay, so it has pretty well defined attributes, as I was saying. So if I click on right click on this add to cart and do an inspect, I see that even though there are multiple add to cart buttons on the screen, they have given a test a data test attribute, they have given an ID to individual add to cart. So this ID belongs to Sauce Labs Bold T-shirt, Sauce Labs Bold T-shirt. I'm assuming if I inspect on the add to cart for this one, the ID would be fleece jacket, Sauce Labs fleece jacket, which belongs to this. So this is a very well-defined way of creating attributes, but not all applications have uh, this kind of a definition, this kind of a process. Uh, if I were to analyze this, so I would, for a second, imagine that this add to cart that we clicked on did not capture the name, did not capture the ID. So I'm going to delete them. This is one of the flexibilities that we have, that we can delete um, attributes. And I would say, okay, I want my relative XPath to be my primary identifier, so I can select it and I can push it up. So now it is my primary identifier, and it's going to be identified or used to identify first by the tool, and then it would move on. If in case it doesn't find it with the relative XPath, then it moves on to try and find it for the next attributes. So that's another level of flexibility. And the third level of flexibility, which is my favorite one, is um, so this add to cart button that I had clicked on during recording. I want it to be driven by the the text that I see on the screen. So if I say, hey, I want to click on, let me just pull this down a little bit, add to cart corresponding to the Sauce Labs Bold t-shirt, or I want to click on add to cart for the fleece jacket or for the backpack. So what I'm essentially trying to do is I'm trying to make the attribute data driven. And that's an important concept, because my favorite way of automation is making the complete automation data driven. What I will do in this case is um, I'm going to inspect on this text, and I see that there is an anchor with a div which has a text. So I'm going to copy this text. I'm going to write my own XPath for this. So anchor and a div which has a text of this. And I found one of one. That means this is uniquely identified. Now I want to click the add to cart button which is immediately next to this, right? So if I inspect on the add to cart, I see this is a button. This is a button which has a text add to cart. So what I can do is I can simply say following, and then button, and I want the first button. Right? So I want the first button. So in this way, what I have done is I have ensured that using this text, I can control which button the automation tool will click on. Right? This is not a concept which is specific to kits. It's a universal concept used across Selenium in order to identify objects. It's just to make your object identification data driven. Okay, now if this is the object that I have, if I'm going to try with bike light, for example, so I'm going to inspect on bike light, and let me copy this text. Let me place it over here. Let's see if it identifies the right add to cart or not. and it indeed identifies the right add to cart button. So our XPath is ready. So we will just copy this XPath and we are going to come to the tool. This is the add to cart button. What I will do is I will remove everything that I have. Another flexibility that we have is just eliminate everything that you have and you can use your own. So I'm going to place the XPath that I wrote. Now in this XPath, this part, the string, is the variable part. This will change depending upon which item I want to buy. So what I will do is I'm going to remove this. I'm going to use um, a concept called a variable object property. So all you need to do is hash, and then I would give the name of a variable. It can be a variable of your choice. So I'm going to say name of item. So hash name of item. So this is the part that I'm going to variabilize. I'm going to make dynamic. But at runtime, I want this data to be fed in from my data sheet, from my script. So now, after the login is clicked and the add to cart is going to be attempted to be clicked, it will not find any object because this variable doesn't have a value. So what we need to do is we need to add a line between 6 and 7, and we are going to take this object, we are going to pull it into our canvas, and we're going to use a property called or an action called set object property. Set object property. What is the object property that I want to set? This is the object property that I'm going to set. Hash name of item. I'm going to copy this and I'm going to paste it in the condition column. Hash name of item. And what do I want to replace this with? And that is the data. So I'm going to say, all right, get me, um, uh, which one was it? This one, yeah, Sauce Labs bold T-shirt. This is the one that we had bought last time. So I'm going to place this. Now we are going to see how we are going to place all these data in our data sheets, again to be covered in a separate video. But in this video, we saw how uh, we can dynamically change the property of an object at runtime using data.
We also have full control over the engine, the working code base behind the scenes. We can import that code base, we can modify it if we want, we can even add more code if we want, and then build a completely brand new jar file for the tool.
If we look at our test automation script, if you look at this canvas, we have objects, we have the description of the action that's going to be performed, the action itself, the input, which is the data which was captured during recording, but we would be changing this and we are going to make it come from an external data source, the condition column, and the reference. The reference is essentially the name of the page to which this object belongs. The only thing that is currently not known to us is uh, the details of these actions, because the object, we just saw how we can modify the object properties, how we can add customizations of our choice. The input is again controlled by us, but the action is something that we have not seen. We are only seeing the actions coming from the drop downs, and the question that immediately comes in mind is, uh, Are these actions configurable? Are these actions changeable, modifiable? And can we add actions of our choice? The answer is yes, and that's why, and this is where I'm going to introduce you to the engine that holds all these actions, and the engine is going to be your go-to item when it comes to any kind of a customization. For me, Eclipse is the IDE that I prefer, so I'm going to open up the Eclipse IDE, and this is an empty workspace that I have just opened up. Um, I've also opened up the location of kits where kits is installed. Well, when I say installed, I mean this is where all the files were unzipped, right? So this is your root location of the tool. In this root location, you have a folder called engine. Now, this is the heart of the tool. So what I will do is I will copy this location of the tool, and I want to see what is there in this engine. So I go back to Eclipse, I go to File, I go to Import, and I will say um, General. Under General, I'm going to click on Existing Projects into Workspace. Next, I'm going to click on Browse, um, paste the location that you copied, that is your root location of the tool. Select Engine, select Folder. The engine will come under the project section. That means Eclipse will identify this as a project, and then all you need to do is click on Finish. So as soon as you click on Finish, the engine gets imported in Eclipse. Now, there are some errors which we are going to fix later on, because I will create a detailed video on how to create customizations, how to read this engine at a later point in time. That would be a detailed video. But here I'm just going to introduce you to the possibilities that we can have in order to break the myth that recording is not good enough. So, if I open up or expand this Java project, I see there are quite a few um, packages that have been defined. Uh, so many packages could be a little overwhelming for us to start off at the beginning. But if I look into the script, I see actions like open, click, set, lots of clicks actually, quite a few assertions which have been defined. I'm going to, let's say, copy this one, assert element display. This is an action that I want to find in the engine. So I go back to my engine. I'll simply click on search. I'll say a file search. I'll place the text that I copied and search. Okay, so it tells me that under the engine, under commands, we have a Java file called assert element, and this is where the code is written. So if I go here, it says this is the package commands. So I'm going to expand this package, and we have a list of Java classes, Java files, which we can read and understand uh, to draw a connection between the actual code and what you see on the screen. So we're going to make an effort to identify open, click, set, the most commonly used attributes or commonly used actions. Um, so under basic, if you click on basic, you will see the first action is click in itself, and it gives you the code that is actually running behind it. So it checks whether the element is enabled or not, and then performs a click action. There are other actions like click if exist, click if visible, and all of these you will find here listed in this drop down. Click if exist, click if visible. if we have to make any changes to this, if we want to make any changes to the existing method, to the existing action, or if we want to add our own action, we can add that code here, and then we can build a jar out of it, and then we are going to feed it to this tool so that our created actions are also listed down in this drop down. We're going to see that in details in one of the later videos, but as of now, the primary conclusion is the way we can identify and we can modify the object properties according to our choice. Similarly, we can also identify and modify the actions that the tool performs on those objects. And that gives us a huge amount of flexibility because the entire code is open to us for usage. So I hope that breaks the myth that scriptless tools are not maneuverable. I hope that breaks the myth that record and playback is very rigid. Well, in this case, it is not. It is totally how you want it to perform. In the next video, we are going to see some different cool features about how we're going to set up the data. Till then, goodbye.